Okay, so what I have for you on this, so we're verifying trig identities. The way I've done this is I've broken this down into what I call our hints. So what are some hints as to how we're gonna verify? Identity just means that we have a truth, an equation that's true. All right, and then verifying is a fancy word. Anybody know what verifying is a fancy word for? All right, what do you do that? Call that in math when you're trying to show that something is right? Proving. Yes, that's one of the cuss words of math, right? We all hate that word, proving. So I'm just going to start by what my hints would be, and then we'll go from there. So my hint on what we would do. So the first thing, my first hint is this. I'm just going to look into sub in an identity and reduce, and the other word for reduce is, to simplify. So really there's no magic right from the start. Can you just sub in an identity and simplify? Okay, now for those of you at home, we've written on the sideboard all of our identities. So you should have you should have 6 reciprocals, 6 cofunction, 6 even and odd, 2 quotient, and 9 Pythagorean that we've collected through all the lessons. That should all be on one sheet of paper. I just have the Pythagorean here. I'm going to erase this. You'll just need to go back through your notes and refer to those. So that way we have room to write on the board. Okay. So subbing. So my first hint is, can I sub in an identity and reduce, which means of course simplify. So I'm going to give you a couple problems like that, and what would be another hint, what would be another hint, and so on. So we'll look for one here. So we'll call this one example 1. So let's see. We have cosine times cosecant x equals cotangent. Okay. Now, the next thing. When I work, I only pick one side of the equation and I try to make it look like the other side. So we're going to prove that this is true. And we have all of our identities listed, so we can sub in any identities. So what I'm going to do here, I'm going to take the more complex side and simplify it. And hopefully until we get the other side of the equation. All right, so basically it's like you already know the answer, okay? And what you're being tested on is, can you reduce or can you get that, okay? So for instance, right now, I'm gonna prove that cosine times cosecant equals cotangent. So what I'm going to do is I'm going to take the left-hand side over here as my problem. And I'm going to see if I can manipulate this using my identities to get cotangent. Okay, that's what I'm going to do. All right. Now, in terms of my hints, what a close hint to number 1 is this. If I'm in doubt, when in doubt, so if I'm not sure where to start, the other hint I have is rewrite in terms of sine and cosine. So, and simplify. Okay. So let's say, for instance, I'm not sure what do you mean to sub in? Okay, so you want me to sub in an identity. I don't know what to sub in. I'm not sure. I can always take anything that's not a sine and cosine and rewrite it as a cosine or a sine. So here's what I mean. The 4 other trig functions can all be written as sines and cosines. So secant we know is what? 1 over cosine. Cosecant we know is what? 1 over sine. Tangent we know is what? In terms of sine and cosine. Sine over cosine. Cotangent we know is what? So all of the other four trig functions can be written in terms of a sine or a cosine or both, right here. We just did it. Two of your reciprocal, two of your quotient identities. So when I look at this, I have cosine times cosecant. Well, if I'm not sure what to do, always take the one that's not a sine or cosine and substitute it. So cosecant can be written as what? What's that? 1 over sine. Okay, there's that. So now that can be written as a fraction. So cosine times 1 over sine is cosine over sine. So all I did is I took cosecant out, I put 1 over sine in. Okay, now I have that. In a proof, you don't have to write your reasoning down. As long as it's known that cosecant is 1 over sine, I don't have to say reciprocal identity for cosecant, I just do it. Okay, and then when I'm multiplying, I'm just cosine times 1 is cosine. So I have this. So now, so again, either when I sub in an identity, which I did, or I rewrite it in terms of sine and cosine, how do I simplify? Well, what I'm simplifying is I'm trying to say, see, is there something smaller that this is equivalent to? So what's in all your identities, what does cosine over sine equal? Cotangent. And cotangent equals to cotangent, and there you go, we're done. So I take the left-hand side and I sub in known values until I get known quantities, until not values, but known expressions until I get the right-hand side. Okay, and that's how you do it. So the good thing about a proof, you know where you're starting and you know where you got to end. You always take what side? The more complex side, and you try to simplify it till you get the that's how you show that they're true. Don't start moving things around. Okay? I don't do that. All right. So I'm going to give you another one to try, similar to this, where you're just going to see if you can follow my hint that's kind of basic like this one. Okay. All right. So we'll just call this example 2 now. I'll run out of room. Well, here, we'll put it here, example 2. Cotangent x times secant x times sine of x is equal to 1. So again, I'm trying to give, and there's more hints than this, but I'm trying to give hints that where you would use these here. So hints for, this is simplifying trig expression. All right. So cotangent times cosecant times sine is equal to 1. So obviously we know which side is more complex. Now the question is, what are you going to sub in? Okay. So we're going to This is the type that I'm hoping you'll take these hints. We're going to sub in identities, and if we're not sure what to sub in, rewrite everything in terms of sine and cosine. That means if I have sine, I leave it alone. So what can cotangent be written as? Cosine over sine. What can secant be written as? And then you have times sine. Okay, well, what happens when you have fractions multiplied? What can you do? I'm just going to cancel. Yeah, if one's in the top and you're multiplying, you got the same thing in the bottom, they just cancel. Cosines cancel. Just like if I had 5 over 3 times 3 over 5. Now multiply. You can multiply and say 15 over 15. I would just cancel. Same thing. Everything cancels. 1 is 1. Done. Okay. Got it? This is analytical trigonometry. This is not right triangle trig. Let's make sure that we understand we're in a whole different realm. Analytical means now we're doing more algebra, doing things kind of by hand more. We're not drawing triangles out. This is a whole different realm of trigonometry. Okay? You can see how it's very similar to algebra. All right, what we're doing. Okay. All right, now that's what 90% of the time, and also if you're taking the ACT, that's what you're probably going to be able to do for the most part. You can just sub in and reduce it, okay? So, now, all right, what's next? Okay, now here's where we get a little bit more, all right, in depth maybe on some of my hints. Let's say I go that route, and what'll happen is, if the problem starts to get worse, then you know you're on the wrong path. It's very simple. If you don't get the simpler side, you know you're doing something wrong. So if the problem starts to get worse and worse and worse, then just stop and try something else. Try again. So here's my try again. Here's my other hints. Let's say I did these, but nothing's working. Sometimes the problem will factor. So I will look to factor. So maybe another suggestion is, can I factor? Then if I factor it, can I sub in identity and simplify? Now the only way I'm going to know to factor is if I have common terms across a plus or a minus sign. So one hint that I have is, could I factor and then sub in identity and simplify? All right, so I'll give you a problem like that. So let's see if you can see what to factor here. I thought I had one. Where did she go? Okay, so obviously on this problem, again, we're trying to prove that the left-hand side equals to the right-hand side. Now, so you can go right away and make secant 1 over cosine if you want, but you're going to see that, all right, maybe that's a good path, maybe not. You could try it that way, all right? So a couple of identities that I'm going to throw out here, just remember that secant is 1 over cosine. And also, anytime I see a square, what identity does that bring into play? The Pythagorean, very good. So I know that sine squared theta plus cosine squared theta is 1. I know that cosine squared is 1 minus sine squared. And I know that sine squared is 1 minus cosine squared. Okay. Okay. All right, so I'm just throwing that out there. Now, there are 2 ways to work this problem. One why don't you go ahead and take a stab at it and see if you can get it. If not, I'll use my fourth hint and show you how I'll use hint 4. Now, obviously, we all want to take the left-hand side and just get it to melt away till we get the right-hand side, okay? All right, so you try it. If you can get it to equal cosine. If not, don't worry, I'll come in and help you. I'm going to show you how I would do it. Okay, so I'm going to work it what I feel is the preferred way, and then I'll show you the other way. So I would look to factor this, okay? And you're going to say, well, what tells you can factor it? I see a common term across a plus or a minus. So minus is, my addition and subtraction separates terms. This is a term, this is a term. They each have a secant. So the way I'm going to try it, I'm going to try my hint number 4. All right, I'm going to see if I can factor it. Well, since each have a secant, secant can factor out. And that leaves me with 1 minus sine squared. So the reason I did that is to unveil identities. See, now by doing that, and by Elise, I had Elise write all the different ways. See, now, by writing your Pythagorean identity 3 different ways, you know what 1 minus sine squared is. 1 minus sine squared is what? Yeah, so when I factor, I'm factoring so that I can sub in an identity. So by taking the secant out, does everybody see why I have 1 minus sine? See, you're saying, well, where's the 1 come from? Because if I distribute again, I got to get secant minus secant times sine squared. Well, I will get that. Okay, it's no different than doing this. This factoring is the same as if I had this problem. X minus xy squared. What is in common? X. Take an x out. What are you left with? 1 minus y squared. Okay? The same. So in this case, our x is secant x. All right. So you can see there's a lot of algebra involved. Okay, so now, what can we do? Well, so I can factor the secant out. Why would I do that? That unveils an identity. 1 minus sine squared is cosine squared. All right, but I just need cosine. So obviously this didn't do enough. Well, we're 1 step away from being done. Always go back to number 3. When in doubt, what do? In terms of sine or cosine. So we have cosine. Luckily, secant is what? 1 over cosine. So we know secant is 1 over cosine. And now what happens? So again, this is like having an x squared over an x or a y squared over a y. What happens to the cosine side? Cancel, and I'm left with cosine equals cosine. Done. Because the right-hand side is cosine. I use my step 4 there. Now, there was another way you could have done this problem, and I'll show you. Because what you're going to learn with trig simplifying is that there's different paths that you can take to get to the same answer. This was, in terms of my favorite topics in undergraduate math, this was up there. I really like these problems. For me, it was like a puzzle. Okay? A lot better than a Sudoku because those get boring after a while. It's the same, just an algorithm. You just got to write it, process of elimination, right? This is a little different. So, what's the other route? What if from the start somebody did what? Anybody else take a different route on simplifying?
Yes.
Yeah, what did you do?
I made sine squared of x 1 minus cosine squared of x.
All right, that's not bad. You could do that. I was thinking a different thing. But then what did you do after that? After you made it 1 minus cosine squared, then what did you do?
Well, I made both of the seconds.
Yeah.
1 over cosine of x, and then I just simplified.
Okay. And it worked out?
I think. I ended up with cosine squared of x over cosine of x.
Yeah.
Does that equal cosine of x?
Yeah, you got cosine squared over cosine.
Okay.
So here's what I would have done, similar to kind of what you did. We'll get there. The other thing I could see a student doing is just changing the secants to 1 over cosine. You change both secants to 1 over cosine. I wouldn't have changed this. I would have just left it now. But here's what I see. So this is going to be another hint in a second. You got 2 fractions. So you look at your fraction. You got 1 over cosine minus sine squared over cosine. So if you have 2 fractions with a common denominator, what can you do? Yeah, make it 1 fraction, 1 minus sine squared over cosine, and then now I'm back to that identity. 1 minus sine squared is cosine squared, and your way is actually also pretty good too. It's similar to this, but not exactly, because you change sine squared to 1 minus cosine squared. Those cancel. All right. There's lots of different routes. I just want to show you an example of when I would factor. So there you go. Now my last hint for this type. If we have grouping, I look to FOIL and sub in identities and simplify. All right. So I'll give you one here that I think that might fit that criteria, okay? Okay. So again, we're trying to, I'll tell you what, I keep thinking of simplifying and not proving. All right, so there we go. So now, I think a mistake, what's the downside of changing cosecant and cotangent into sines and cosines? What becomes the negative of doing that if you did that? But if you change cosecant, what does cosecant equal in terms of sine or cosine? 1 over cosine. So here's where there's a negative with this. If I change cosecant to 1 over sine, and what does cotangent equal? Cosine over sine. Okay? I'm introducing fractions into the problem, and now that becomes an issue. Okay? So sometimes it's not the best route. On this one, I would not do hint 3 when in doubt, because I'm not in doubt. I gave you another hint. So my hint was this. If I have grouping means like FOIL, like 2 sets of parentheses. If you had that in regular math and regular algebra, you would just FOIL it out. So you FOIL the same way here, okay? Now, just to make sure that we're clear, when you multiply a cosecant times a cosecant, it's a cosecant squared. So the talk I gave you before, if we do cosecant times cosecant, that is cosecant of x quantity squared. But since nobody wants to write that with the parentheses, we put the square after the last letter and before the variable so that we know the whole thing is squared. This is the notation to say the whole thing is squared. So what I would like you to do is FOIL it and see what happens. Do first alter. Now when you do cosecant times cotangent, it's just cosecant times cotangent. Okay. So if I have grouping, I will try to FOIL it and see if I can simplify from there. And these are my 5 main hints that I have with fractions, and I'm sorry, without fractions, and then I'll go with fractions in a second. So instead of subbing in, let's just FOIL it, okay, and see what happens. So after you FOIL, look to see if anything will cancel. Can you sub in any identities and go from there? Okay, let's start going through this and see what happens. First, cosecant times cosecant, we say cosecant squared. Outer, cosecant times cotangent, we just say cosecant times cotangent. That's it. Now, once I pick the order, here when I do inner, I'm not going to say cotangent cosecant. Since I put cosecant in front, I'm going to keep it there. So here, when I do inner, cosecant times cotangent, I'm going to say cosecant times cotangent like that. If you wrote cotangent times cosecant, you need to know that these are the same term. Okay? So one's positive, one's negative. All right, then last, minus times a plus is a minus, cotangent times cotangent is cotangent squared. So anything I can do right away, cancel the middle, those cancel. Those are opposites. Okay? It's like having an xy minus an xy. Now I'm left with cosecant squared minus cotangent squared. If you go over to the identities on Pythagorean, cotangent squared plus 1 is cosecant squared. And then we also wrote 1 is cosecant squared minus cotangent squared. That is in your earlier work in chapter 4 where we wrote all these out for the ones at home. Okay? So cosecant squared minus cotangent squared is 1. Okay? But if you don't FOIL it, you're not going to get that. Okay? How did I know to FOIL? Grouping. That's right. Okay. So I have 2 more hints. And I don't know how good these are, but really that's about it. So when you start doing these substitutions and everything, you could get 2 fractions. If I have 2 fractions added or subtracted, I'll just put or, added or subtracted, then typically what I'll do is get a common denominator if I don't already have one and make into 1 fraction. See if I can find one of those. go with. Sorry, I have to just keep erasing here, but we just did FOIL. Okay. So here's one where I have two fractions here. Like, what do I do? Okay. Here's a good example. All right. So again, we're trying to prove. All these are proofs. Okay, I'll move out of the way. Obviously, which side is worse? Left-hand side. So we're going to take the left-hand side, and can we get it to the right-hand side? Notice we have two fractions. Okay? Notice the right-hand side has no fractions. All right? So somehow I got to go from two fractions to no fractions. So I'm going to start by, if I have two fractions added or subtracted, I'm going to get a common denominator. Now, how can you always get a common denominator? No matter what the denominator is, what's always the common denominator? You multiply. That's exactly right. So the common denominator is 1 minus sine times cosine. Okay? All right. I'm not telling you that this is going to be a nice problem. I'm just telling you how you would do it. Okay? So the common denominator is the product of these two. But now look what happens. So that means we're going to multiply the left-hand fraction by what? Cosine. And you'll see you'll pick up a square up here. And that means we're going to multiply the right-hand side by the right-hand fraction by 1 minus sine. Let me give you a hint. Don't worry about multiplying out the denominator. Because we're going to need things to cancel at some point anyways. Okay? So what are we going to do? We're going to do hint 6. Get a common denominator. All right? And then I'm going to just show in red here what we would multiply by. And I'm telling you right now, when you do this, it's really the top that we got to change. So all I would do, multiply my left fraction by cosine over cosine, and multiply my right fraction by 1 minus sine, 1 minus sine. So your denominator, think about it. Your denominator is not going to be pretty. It's just cosine times 1 minus sine. Okay? So make that multiplication. You can see it. Sorry, it's not the best there. That's a 1 minus sine. Okay. So I always say this when you're doing algebra and all that. It usually gets pretty nasty before it gets good. So if it looks very bad, don't panic. There should be some simplifications, okay? All right, so let's see what happens. Now, notice up here, this is a 1 minus sine times a 1 minus sine. You got grouping again. What are you going to have to do here? Yeah, you got to FOIL that. Cosine times cosine, we get cosine squared, so we don't need to panic there. And let's see what happens. And this is, in terms of the difficulty for this section, this is the toughest. If you get one like this, you won't have many of them, you just may have one. But I can cheat a little. I know I got to get this, which means, let's think about it. Go one step back. I know I got to get this. Secant is 1 over cosine, which means I may get this at some point, 2 over cosine. These are all the same. So I'm thinking ahead. How am I going to get a 2? All right, go ahead and go through it. See if you can. So don't worry about multiplying the bottom. Just multiply the two tops and combine them. And then we'll look to see. And like on you're in like level, you're on Super Mario at the castle trying to save the princess or whatever. You're at the difficult spot. Those hints are nowhere, so when I write my book, I'm going to put this in there. These are the hints I use. They're not 100% right, but I think you need some kind of guide when you're working this stuff. Okay, so let's have a look. Let's see what happens. So right here, when I do this, this becomes cosine squared. So I got that. Now I'm going to do FOIL here. 1 times 1, 1. 1 times negative sine is negative sine. Negative sine times 1, negative sine. Negative sine times negative sine is plus sine squared. Okay? All over cosine times 1 minus sine. Let me ask you this, CJ. Using, like we're going to cheat a little, right? We're cheating because we already know the answer. So if you look at the answer, right, 2 over cosine, 2 secant, mainly look here, 2 over cosine. What do we have to get rid of on the bottom? Yeah, you know this has to cancel. So somehow I got to get a 1 minus sign up here so that these can cancel like a factor. So the nice thing about proving is we can kind of, just like we're looking in the back of the book and it helps us work through it. So now this is where this is the tough part, right? So now what might you do with these 2 minus signs? You would call them what? Minus sign, minus sign? No. Minus x, minus x. What's this? Minus x, minus x. What is that? Negative 2x. A negative and a negative next to each other, you combine it, make it 2. So the only thing we're going to do is going to make this minus 2 sine x. Now, okay, there's an identity on the board. It's hard to see it, but there is a 1. So notice, after you do your 2 fractions, add it or subtract it, get a common denominator, and make into 1 fraction. There's an identity. Anybody see the identity? It's not in the bottom. That's part of it. You're halfway. Yeah. It's hard. But this, cosine squared plus sine squared, see if you scoot them next to each other, they equal what? So you can actually, since it's cosine squared plus sine squared, you can actually just cross them both out and put a plus 1. Because cosine squared plus sine squared equals 1. All right? So let's see what we have now. On the top, we got 1 and 1 minus 2 sine x. So we got 2 minus 2 sine x on top over cosine x times 1 minus sine x. Now, all right, everybody see where this 2 came from? See, it's a plus 1, and cosine squared plus sine squared is another plus 1. Okay? Now, remember what CJ said? He said the 1 minus sign, we have to cancel it somehow. So I need a 1 minus sign factor in top. So let that marinate for a second. See if you can catch up with my work there. Yeah, what's that? That's exactly right. Notice the factoring again. So what Rebecca said, she said factor the 2 out. If you factor a 2 out, look, and we know we need a 2 in our answer, see? We know we need a 2 times 1 over cosine, or 2 over cosine. So if we factor the 2, that leaves 1 minus sine x. And we got cosine times 1 minus sine. And those cancel. And there you go. There's your proof. 2 secant is 2 times 1 over cosine, or 2 over cosine. So that's 2 secant x. Because 2 over cosine is secant. So that's what Rebecca said. She said factor the 2 out. We factor the 2 out. You're left with 1 minus sine x's. And those cancel. Okay, my last hint is, I should have done this one last because it probably burns you now. You're kind of like, oh my gosh. I don't want to do these problems. My last hint is the simplest, or it's simpler. If I have a fraction over a fraction, what's always the hint in math anyways? A fraction divided by a fraction, what would you do? Yeah, flip and multiply. So if we have a fraction over a fraction, which could happen, I'll show you here in a second, just flip denominator and multiply, okay? So I promise now, this goes from this beast problem down to an easy one. And don't worry, you have the video too, so you'll be able to go back. So this is my last hint. All right. All right, let's try this one. And if we go in and I see any other problems that don't match that or whatever, maybe we can try something else, but for the most part, that's got it. So, last one, tangent x over secant x. Okay, simple, we're again, oh, it equals 1. Sorry, but it's just easy if I have something that all cancels. All right. So, no, it does not equal 1. It equals sine. Sorry. Okay. All right. So now we got 7 hints on the board. Let's start off. Brandon, what side do you think we should work with? What side is going to be our problem? Yeah, the left-hand side is worse. Okay. So now we know where we're going to start. Okay, now. The question is now what do you do? All right. So don't panic. All right. When I go to the left, there's nothing obvious. So if there's no common factors and there's no grouping. Now notice I put this for a reason. A fraction over a fraction, not just one fraction, but if we have 2 fractions, fraction divided by fraction. So what's my when in doubt? Do try that. Because look, you need to get a sign somehow. All right? So change it all to sines and cosines. See if you can follow this number 7 hint, and it should melt away and you get the answer. And we'll stop today. This should be the complexity of the simplifications that are on the ACT. If you're going to take the ACT in March, are we all taking it again? In March? Sir?
I was thinking about taking it in April.
Yeah, but isn't it offered to juniors here in March? That's juniors, right? Seniors, no, you can't, you don't take it. They don't offer it to you. Right, but you can't take it again if you wanted?
Not by the school. We have to sign up for it.
No, that's what I was asking. Could you take it here? They said no. Okay. But if you do, take it in April or whenever, now I think you'll be better prepared for those. See, the problem is, let's think about it. If you're a junior, a lot of juniors are in IM3, right? But the problem is they don't teach trig in IM3. But then you're getting trig on the ACT and you don't know what to do. So, I don't know. I mean, I can only tell you the reality. I can't give you a solution. All right. So when in doubt, what's tangent equal? Sine over cosine. What's secant equal? 1 over cosine. Look what we got. It's magic, but we got a fraction over a fraction. What's always the rule? When you divide by a fraction, you flip and multiply. So we'll just say sine over cosine times cosine over 1. And what happens to the cosines? Stop it.